the early 1600s, I have discovered that this never works for n greater than 2.
Did he show how?
He said, no, this was the best part. He said, and I've thought of an elegant little proof of why that's true, and I don't have room for it in this margin.
Right.
This became known as Fermat's last theorem, because Fermat actually did this sort of thing a lot. He said a lot of stuff. Some of it he proved, some of it he didn't. Most of the stuff he said but didn't prove turned out to be true. A few of them did not. But within 30, 40 years of his death, it had all been figured out one way or another, except for this. Guess when this was proven?
Last year.
1995. The proof took over 200 pages. I love little Fermat's little, and I have an elegant little proof that I don't have room for in this margin.
Yeah.
No one knows what Fermat was talking about, actually, because the proof was over 200 pages and included several studies of math that had not yet been invented, including mathematical induction, which didn't exist in his time. Mathematical induction was the basis of this, so God knows what Fermat was talking about, or whether his proof would have worked.
Who did the proof?
Andrew Wiley.
Watch Andrew Wiley. He dies, goes to heaven, sees the guy, and he's like, dude, you could have just simplified it by doing this.
That would be hilarious.
That'd be the best comic
if Fermat really
ever.
did have a 3-page proof that no one's ever thought
That'd
of.
be the best math joke comic strip ever.
Well, Fermat's last theorem was actually famous. Like when I was in college, Fermat's last theorem was famous as one of the last great unproved mysteries of math. 1995, this guy did a 200-page proof. And really, there are barely dozens of people in the world who are capable of following what he did. It's some crazy stuff.
That'd be hysterical.
Yeah, so we're not going to use.
Heaven, he's like,
it would be.
We're
not going to use mathematical induction to prove that.
Right.
Yes.
Why not? Riemann hypothesis?
Yeah, I'll get right on that. It's only been It's only been stumping geniuses for 150 years, and it involves imaginary numbers in 3 dimensions and God knows what else.
Right.
That's fun.
Okay. Here's another way to use mathematical induction. The same principles are the same, but it's a little bit different. And Jesse, this is this much more practical. Okay? But only this much. It's still pretty abstract.
The hypothesis is more practical than this.
Okay. Yeah, in cryptography it would be huge. The ability to predict prime numbers past with certainty. Okay, prove that 2 is a factor of n squared plus 5n. And this means whenever you see an n, unless it says otherwise, go ahead and assume for this chapter it means positive counting numbers. Whole numbers, usually 1 on up, sometimes 0, but for now just 1 on up. No negatives, no decimals. Okay? So what this means is if you put any positive integer in for n, you'll always get an even number. Is it?
Why are they using?
I don't know. Wait.
You know right now that if you put 1063 in there, it'll come out even?
I thought you said no.
They said any even number.
No, I'm sorry. No negative numbers, no zeros, but yeah,
okay.
Just all integers. Odd numbers are.
I guess it works.
Okay.
You guess it works? Okay.
Wait,
I did 1, 2, and 3.
You can put in any counting number. Okay?
I put 1, 2, and 3 in.
And you're done. That's good enough. As far as you're concerned, it'll always work from there. Okay. First, step 1. Prove that it works for 1. Is 1 squared plus 5 times 1 even?
Yeah.
Yes. Okay. Now here's a big leap that someone smarter than me has proven always works for mathematical induction. Okay? You can, in this case, you can assume that this is your kth term, and you only have to prove your k plus 1 term works.
Huh?
Okay?
So 6 and
well, 6. Well, not by plugging in the next number, but in general. This is a little trickier. We have to prove this in general. So what we're going to do is.
Why do we have to prove anything?
Because otherwise you'll fail this course. Let me put it in simple terms for you. So now what I'm going to do is I'm going to put k plus 1 in for n. K plus 1 is, so that's going to be k plus 1 squared times 5 times k plus 1. And now what I have to prove is that this will always be even.
Wait till k is 0.
K could be anything.
K can be anything, but it's got to start with 1.
Wait.
But we have to prove it in general.
Well, then 1 doesn't
That
apply.
gives you 7.
Wait, does 0
Hold
apply
Hold
to
on.
this?
We're keeping K general.
No, okay.
Okay.
No.
Hold on. So now, I'm going to double check that I've written this incorrectly because I don't want to miss. Yes, this is it. Okay, now, I'm going to start working
Wait,
this
did you
out and
just
see
say
where
that
it goes.
you wrote this incorrectly?
No, I want to make sure I wrote it correctly. Okay. If I FOIL this, I get K squared plus 2K plus 1, correct?
Sure.
Okay. Plus 5K plus 5.
Wait,
Right?
where'd you get that? Oh, the second one.
Distributing, yeah.
Wait, well, if you use 0, then...
No, I can't put 0 in.
Oh.
And I said, remember, if you just see n has got to be 1 or bigger. It can sometimes be 0 with our sequences in series. It's for these, for mathematical induction, it's always 1.
You never plug in a number for K.
Nope, never. Never. That ruins the whole point of proving it always works out to infinity. Okay, so K squared plus 7K plus 6.
It does go into, working columns.
Thank you.
No, like you can,
Okay, hold on a sec. Let me show you this
Emphasize
trick. Okay, I'm gonna use the associative property. Yes. Okay, and I'm not gonna. Right, I could do that, but that actually won't help me as much.
well, it is possible.
It is possible, yes, because I can do K plus 1 times K plus 6. But that doesn't help me as much as what I'm about to do helps.
What are you going to do?
I'm gonna split this back up into K squared plus 5K. Because that's my original statement, n squared plus 5n. And then what's left is 2k plus 6. Alright? Does this equal the statement before it?
Yes.
Remember the basic rule of math? The easy part of this is you're allowed to do anything you want to as long as it equals the statement
Then
before
why
it.
did we ever do that?
Well, we didn't have k squared plus 5k anywhere.